refraction, or bending of the waves. This can happen in several ways, and may be a hindrance, or it may be a help to radio wave propagation. If radio waves or light waves pass through one medium and then through another, they will bend or refract because of a change in velocity, such as light through a prism. This graphic shows a straw which has not yet been inserted into clear water. Now, when it is inserted into the water, it appears to bend. This is because the light waves travel in water at 75% of the speed that they do in air. The same occurs to radio waves in the ionosphere, as they pass into a more densely ionized, that is, negatively charged, layer. This ionospheric refraction is very useful, as it causes the radio wave to bend back towards Earth. Refraction decreases as the frequency of the radio signal increases. Equally useful is atmospheric diffraction. In the low and medium frequency bands, radio waves tend to refract or bend to such an extent that they remain in contact with the Earth's surface, which increases range, possibly to thousands of kilometers. This bending also occurs in the VHF band during some meteorological conditions, which results in a radio wave hugging the Earth and increasing range. This effect is known as subrefraction. The necessary conditions are a decrease in relative humidity with height, temperature falling more slowly than standard, and a high pressure system, typically where warm air flows over cooler surfaces. Subrefraction occurs in conditions of increased relative humidity, lower than isotemperature and low pressure, typically where cold air flows over a hot surface. It results in reduced range. However, not all refraction is beneficial. Coastal refraction occurs because a radio wave travels faster over the sea than it does over land. As a result, any wave that crosses a coastline at other than 90 degrees will bend slightly towards the medium in which it travels slower, namely the landmass. Again, the degree of refraction decreases as the frequency of the radio signal increases. Now let us look at the ways in which radio waves are propagated. There are three ways in which electromagnetic energy travels from a transmitter antenna to a receiver antenna. Two of them, surface waves and space waves, do not reach the ionosphere, and collectively they are called non-ionospheric. The third method of propagation, the sky wave, uses the ionosphere.